So hello everyone, this is my first video and the title of video is Resistance and its role in robot and robotics, presented by Control Path Robotics. So let's begin. So first of all, what is resistance? Resistance is the opposition to the flow of electric current. Think of electricity like water flowing in a pipe. By this analogy, we understand how resistance affects the flow of electrical current in a circuit. So here voltage is equal to water pressure, current is the flow of water, and resistance is the diameter of the pipe or how narrow the pipe is. So the narrower the pipe, the harder it is water to flow. Similarly, in a circuit, if resistance is high, it is harder for electrical current to flow. The unit in which we measure the resistance is ohms. Now we are going to talk about the basic formula, Ohm's law. As you know, as per the Ohm's law, voltage is equal to current into resistance. We measure voltage in volts, current into amperes, and resistance into ohms. This equation is the foundation of electronics and robotics. So, the main use case of resistance is controlling current. If there is no resistance present in the circuit, too much current can flow and it will eventually damage the components. Device that we use for resistance is known as resistor. Now we are going to see resistance from a robotics point of view, or how resistance is used in robotics and its effect on the real robots. So for starter, we are going to talk about motor speed control by resistance. As you all know, the formula of power is power equal to voltage into current. So how resistance affect this thing? For example, in this circuit, if resistance is high, which leads to less current. If current is less, then motor runs slow as power is low. Torque will eventually decrease. But if in the same circuit resistance value is low, so more current will follow. Motor run faster as there is more power and torque will increase. So in overall, resistance affect the speed of motor, torque of motor and the efficiency of that motor. In robotics, it is mandatory, or you can say a really needy thing, that we should choose proper resistance because it leads to smooth movement of robot, battery efficiency and no overheating. Now we are going to talk about effect of bad and improper rated resistance. So as we all know that robots run on batteries. If resistance in wire or component is too high, current will not flow smoothly. So the energy is going to be wasted as a form of heat. Battery drain faster, and as in the previous example we see that higher resistance, lower motor efficiency. Same thing happen here. Robot performance will drop. When current flows through resistance, we know formula of power is I square R. If there is too much resistance, it will turn energy into heat, damage the motor drive, burn the PCB tracks, and reduce efficiency. Now we are going to talk about resistance as a voltage divider, and it is the one of the most important case of resistance and its uses. So in this circuit diagram, you can see that VCC connected to resistance 1 is connected to resistance 2 and ground. On resistance 1, we have output. So the formula of voltage output will be equal to VCC into R2 divided by R1 plus R2. In this case, the output voltage depends on the ratio of the resistance, not the input voltage only. How this is important, we'll see in next slide. So, as we know, microcontrollers like Arduino ESP are commonly used in robotics applications. And the problem with that is they cannot measure resistance directly. They only measure the input of voltage. So by using previous formula, we convert resistance into voltage and then read it using analog pin. Practical example, light sensor. In LDR, it is a type of light dependent resistor in which resistance value change on light type, like if bright or dark. If there is bright light, high low resistance. In dark, resistance get high. So as per the light change or light intensity change, resistance change, which lead to voltage change. Then we convert that voltage change into digital reading, and by that we perform robotics action. Another example we are going to talk about is potentiometer. It's a rotating knob. When we rotate the knob of potentiometer, its internal resistance gets changed, which leads to output voltage change. As we know, microcontroller reads 0 to 5 voltage at 0 to 123 for 10 bit analog to digital conversion. In robotics, this configuration is used for servo angle control, speed control, manual robot direction control, and calibration tuning. As we rotate the knob, voltage change and the robotics arm follow or move according to that change. That's the analog control in robotics. Why this is so powerful? Voltage divider allow robot to convert light, temperature, pressure, position, force into readable electrical signals. Without voltage divider circuit, if we use microcontroller and sensor would just be changing resistance and microcontroller would not understand them, because microcontroller only understand change in voltage, not change in resistance. Now we are gonna take a real robotic example. So let's talk about line following robot. As you know, in line following robot, there are two type of surface, white surface and black surface. On the white surface, more light get reflected comparing to black surface. Infrared sensor change resistance based on the reflected light, which then converted into voltage by voltage divider. Then the changed voltage transferred to microcontroller, which reads that value and guide or navigate the robot right or left. So where this intelligence starts from initially, to resistance dividing voltage. From engineering insight, voltage divider is used for resistance to voltage converter. A robot is full of physical quantity which we measure using sensor. In sensor, we measure resistance change, then using voltage divider, we change that resistance into voltage. Then voltage converted into digital value, which is used by microcontrollers or any that kind of circuit board, which then command robots to move from one place to another place or any movement that we are programmed in it. So this is how mathematics and electrical engineering create robot intelligence. At final, we can say that resistance is not just a small component on board. In robotics, it plays major roles in controlling current, protect components, affect performance, enable sensors, impact battery life, and also ensure signal stability, which is crucial for a robot. So that's all. Thank you for watching the video till the end. Thanks.